Hello, so my name is Leah Saad, and today I chose the composite pattern for my presentation. I've implemented it through a fully functional web application that acts as a nested task manager. So in this app, users can create projects, add tasks and subtasks, and view them as a hierarchical tree in the browser. Throughout this presentation, I'm going to walk you through what the composite pattern is, why it's useful, the specific problem it solves, how I implemented in the code, and some real world pros, cons, and examples. So I'm going to start with the intent of the pattern. So first of all, the intent of the composite pattern is to allow us to represent whole part hierarchies in a way that treats both the whole and its parts uniformly. This means we define a common interface for both single objects and the compositions of the objects. Then when we perform operations like render or execute, we don't have to worry about whether you're dealing with one item or a group. We treat them as the same. A common real-world analogy is the file system. So a file is an individual item, like a leaf, and a folder is a container, like a composite. But both files and folders support the same operations. You can delete them, move them, or rename them. That's the composite pattern in action. So basically, this pattern gives us a clean way to manage complex nested structures where everything behaves the same way from the outside, even if it's built differently from the inside. So now let's talk about the problem that this pattern addresses. So in many software systems, usually UIs and data management tools, we often deal with hierarchical or nested data structures. For example, a project with tasks or subtasks, a menu with items or submenus, or a graphical UI with containers and child components. These structures require us to apply operations recursively, such as rendering, validation, or saving data. Without a composite pattern, we usually end up writing duplicate logic. So one version for handling single elements and another for handling collection or groups. And that quickly becomes hard to maintain. So what the composite pattern does is solve the problem of allowing a single interface that covers both use cases and recursive behavior that flows naturally through the structure. So in other words, we don't need to know if we're dealing with a simple task or a complex project. We just call the same method and let the object handle it appropriately. So here's a simplified UML diagram of the pattern that I created. So this UML diagram illustrates how the composite pattern is applied in my web-based task manager. The task manager class defines the common interface. So simple task is a leaf that has no children, while composite task is a composite that can hold multiple task objects. So both the leaf and the composite share the same interface. So this enables recursive operations. Now, the hollow triangle arrow shows inner inheritance from the abstract task. The solid diamond indicates that a composite task is composed of many task objects. So at the top, we have the task abstract class, and this is the shared interface. Then we have two subclasses, the simple task, which is the leaf, and the composite task, which is the composite node that can hold another task object. So this mirrors the gang of four design exactly, and it's the structure I use in my project. My application is a task manager built to demonstrate the composite pattern in a real interactive way. The idea is simple. So users can define a project, which is a composite, and then add tasks under it. Those tasks can be either individual tasks, simple tasks, or other composite tasks like subtasks or sub-projects. Each component, whether it's a simple task or composite, is rendered in the browser as a visually nested tree structure. So the hierarchy is immediately clear. So I built this using pure HTML, CSS, and modern JavaScript, and specifically ES6 classes. I didn't use any libraries or frameworks like React or Vue because I wanted to stay close to the core of the composite pattern and just focus on the actual object structure and recursion. So I emphasized in this project was to keep the structure clear and easy to follow, make sure that the rendering dynamic and recursive, and ensuring that the implementation maps directly to the textbook definition of the composite pattern, which is one-to-one. So it's a lightweight, no-frills app, and it shows exactly how this pattern should work in practice. Now, the task class, this is the abstract base class task, which defines the interface for all tasks. So this class includes a name, which describes the task, a render method, which all subclasses are required to implement. So the render method in this base class throws an error by default so that any subclass must override it. This is how we enforce consistent behavior across all child classes, a concept borrowed from classical inheritance. In composite, this abstract class is referred to as the component. It defines a common structure and operations for both leaf and composite nodes. Now, the symbol task, which is a leaf, it extends the base task class and represents a leaf node. This class is designed to handle tasks that don't have any subtasks, so it's atomic and self-contained. Its implementation of the render method simply returns an HTML string that displays the task name, and along with some indentation to position it visually in the tree, obviously. So it does not have any child management functions like add or remove because it's not a composite. It's a final indivisible unit. Now we have the composite task. So the composite task is where the complexity and the power of the composite pattern comes in play. This class extends task as well in addition to the name. It also contains an array called subtasks, which holds child objects. These children can either be simple tasks or other composite tasks. It also gives an add method to allow dynamic addition of child tasks. And the render method first renders its own task as a heading and then recursively calls render on all its subtasks. So this increases the indentation every time to reflect the hierarchy visually. This recursive behavior is the key that makes the composite pattern work. So the pattern doesn't care how deep the tree goes. The code stays clean and the output always renders the full nested structure correctly. So this is a screenshot of the working demo of the app in action. So you can see a top level project called semester project, and under it we have tasks like do research, write report, and a nested project called prepare presentation. Inside that we've added two sub tasks, which is design slides and practice speech. So this visual output proves the recursive render logic is working correctly and follows the composite structure. Now, the mapping app to composite pattern, this table maps each part. Excuse me. This table maps each part of my code to the standard composite pattern rules. So the task is the abstract component, the simple task is the leaf, composite task is the composite, and the client is the browser and the user interacting with the app. So this implementation is faithful to the pattern and reflects the Gang of Four's original intent. Now, the advantages are for the composite pattern are uniformity. So both individual tasks and group of tasks follow the same interface and behavior. This simplifies client code significantly. The second is recursion. Since composites can contain other composites, operations like rendering or searching can be handled elegantly and recursively. And thirdly, it's extensibility. You can easily add new types of tasks in the future without changing existing code. And then fourth is the maintainability. So the code stays clean and consistent, and we avoid special case logic for different object types. So as one of the quotes from the assigned reading said, the composite node extends the basic node class with the collection behavior and interface. So that's exactly what I did with composite task. Now, the disadvantages here could be the complexity grows with depth. So deeply nested hierarchies can become difficult to manage both visually and in memory. And the memory usage, so recursion and object references can take up a lot of memory if it's not managed properly. And then there's interface mismatch. So it can be tricky to force leaf and composite classes to follow the same interface exactly. You have to use methods like add or remove that don't make sense for a leaf. So as Ralph Johnson noted, which is a source that I found, in practice, the interfaces are usually almost the same, but not quite. This quote is a good reminder that while the theory is clean, real-world implementation often requires small compromises. So now we have real-world cases. The composite pattern is widely used in the real world. So some practical examples include file systems where folders can contain files or other folders, but everything supports the same operations. Then we have the graphical UIs where the windows contain panels which contain buttons or sliders. And then we have the menus, which have drop downs that can contain items or nested submenus. And then we also have stuff like document editors, which are documents contain sections, which contain paragraphs, which contain text runs. So any system where you deal with recursive structures and need uniform treatment of single and group elements is a perfect candidate for the composite pattern. Now, this is a summary basically. So I built a working web app that implements the composite pattern that I'm going to be showing right now. And I followed the classic structure of the Gang of Four book, and I used JavaScript classes and recursive logic to render a nested task system in the browser. So I built this from the ground up for this assignment. It's pretty simple and nice and easy to look at. So as we can see, um, I built the folder composite pattern to do app. We have the style CSS and the script JS. This has the code as you can see in the slide. And then when I click on index.html, it's going to take me to Chrome and show me the composite pattern that we discussed earlier, which was the semester project. And under it are the subtasks: do research, write report, prepare. As you can see, this is a composite pattern. It has a hierarchy, a tree, leaves, and everything that was discussed. So thank you so much for your time today. I hope you like my nested task manager web app.